Okay, now chapter 8, in many ways, it's an extremely important chapter because we're going to be getting into what are called Taylor and Maclaurin series later on in the chapter. But to get there, we need to learn a lot of information about what are called sequences and series. So a sequence is an ordered list of numbers. If you go in section 8.1, the definition of a sequence is a list of numbers written in a definite order. So what I have written here in the example are three different sequences. And for each sequence, we want to find a formula that models the sequence. So let me give you a moment to copy these three examples down, and then we'll go over the solutions. Okay, so, all right. So let's take a look here at these sequences one at a time. So the first sequence starts off, let me see here. We have the sequence in A there. What's the first term? What's the first term of the sequence in A? Well, that's right. The first term is a half. So that's right, Yonatan, that's right, OPME, a half. The second term is 2/3. The third term is 3/4. So this is how we denote the, first term is A sub 1, second term is A sub 2, third term is A sub 3. Those are some terms of the sequence. Well, what we want to do is we want to figure out what the nth term of the sequence is. In other words, for this sequence of numbers, and this is how you denote a sequence, one way to denote it is to write your list inside these brackets. What would the nth term be of the sequence? What would the formula be for this sequence in A? What would the formula be for that sequence, the general term or the nth term? What do you think it would be? Well, let's go to the solution. Let's take a look. Okay. Well, hold on. Wait, we might have a 1 plus n over 2 plus n. Well, I'll tell you what. Okay, hold on. Let's go to the solution. So you're not far off, but let's take a look here at this part here. So you see, what we want to try to do is we want to try to relate the term of the sequence, whether it's the first term, second term, third term, we want to relate it to what we're getting. So a half, I notice, is 1 over 1 plus 1. 2/3, you might notice, is 2 over 1 plus 2. 3/4 is 3 over 1 plus 3. So you see, in each term, like here's a 1, here's a 2, here's a 3, here's a 1, here's a 2, here's a 3. So you see the general pattern is the nth term. Oh, and also above here, you have a 1 here, you have a 2 here, you have a 3 here. So the general pattern of the sequence is the nth term, or I want to say it to use there's a lot of ways to say it, but the nth term, that's what the book calls this, the nth term. The nth term is n over n plus 1, where n goes from 1, 2, 3, and so forth. So traditionally, your first term of the sequence, you let n be 1. Second term of the sequence, n is 2. Third term of the sequence, n is 3, and so forth. So this formula here, the nth term equals n over n plus 1, will generate this sequence that goes on and on and on and on. Are there any questions on that? Okay, and so these are like, they're really like little puzzles sometimes. So if you're trying to find the formula for the sequence, it's like a little puzzle that you have to figure out. Yes, Susanna.
I see it gets more complicated on the second one, but it seems like there'd kind of be infinite ways to write a simple expression for these. Like we just have to kind of mess with it until.
Yeah. There are multiple answers. There are multiple answers possible. Indeed. You could have multiple answers. Now, the thing is, if you had like let's say you tried, like one of our students said, well, could the nth term be written as n plus 1 over n plus 2? Would that be possible? Well, the thing is, if we did like a sub 1, that would be 1 plus 1 over 1 plus 2. That would get you 2/3. A sub 2 would get you 2 plus 1 over 2 plus 2. So Jonathan this was his suggestion. He was on the right track, but the problem is the first term, it doesn't match the first term in the sequence, you see. Now, if n were allowed to be 0 starting off, then you'd be okay. But generally, we go a sub 1, a sub 2, a sub 3. That's right, Jonathan. It's right technically, but doesn't match the first iteration. And Susanna, you're right. Some problems you can have multiple answers. So like this second problem here, the second sequence, You have, right, the terms were negative 2/3, 3/9, negative 4/27, 5/81, and so forth. So looking at that, you can see that this sequence is what's called an alternating sequence. The first term is negative, second term's positive, third term's negative, fourth term's positive. It's an alternating sequence. And in the denominator, you have a 3, a 9, a 27, an 81. Those all relate to 3 somehow. So what you can do, like 3 is 3 to the first. 9 in the second term in the denominator is 3 squared. 27 in the third term of the denominator is 3 cubed. So it appears that, and then 81 in the fourth term, 81 in the fourth term can be written as 3/4, 3 to the fourth power. So I think we have a kind of idea how to write the denominator. And then for the numerator, the negative, positive, all we need to do for that is put in a -1 to the first power for the first term. The second term would be -1 to the second power. See, you relate the 2 to the second term, the 2 there. And you know, that gives you a positive. And so then the third term, -1 to the third power. Okay, that'll give you a -1. -1 to the fourth power in the fourth term, that'll give you a +1. So that takes care of the positive or negative part. And then finally, you know we have 2, 3, 4, and 5, and 6, and so forth. So you see, you can get those numbers just by you know, 2 is 1 + 1, right? 2 is 1 + 1. 3 is 1 + 2. 4 is 1 + 3. 5 is 1 + 4. So you have to play around with it a little bit, but eventually you'll get a formula that works. You'll get a formula that works. Most students will wind up with the same formula. Okay, but you can have, as Susanna was commenting on, you can have different formulas. You can have different formulas that will work. Are there any questions so far? All right. All right. Well, now part C. Okay, C. We had the sequence 5, 1, 5, 1, and it'll just continue. That's the pattern. So the first term is 5, second term is 1, third term is 5, fourth term is 1, and so forth. That's what this sequence is doing. This one's kind of a tough one. This one's kind of a tough one. But let me go to the next page and I'll show you the answer. Okay? This is how you do this one. I'm not saying this is the only way to do it, but I note that the sequence, if we were to draw a picture of the sequence, okay, if we were to draw a picture, okay, and you can plot sequences, I'm sure, in Desmos. I'm sure that's possible. Hold on here. Let me see. So the first term of the sequence, I'd like to try to, the first term of the sequence is 5. Okay, and you see I have that like where, let me just maybe, where n is 1, you see up there, I've put a dot at 5. Okay, and where n is 2, sequence equals 1. When n is 3, sequence value is 5. When n is 4, sequence value is 1. And so really this is just a picture of the sequence. And the 1 and the 5, the 3 is halfway between 1 and 5. So you could say, well, really this sequence, to get it, if I were to take 3 and then add 2 and subtract 2, add 2 and subtract 2, add 2 and subtract 2, that would give me, that would take me back and forth between 5 and 1. But how do you add 2 and subtract 2? Well, you can add a term that says 2 times -1 to the n plus first power. So for instance, a sub 1 would be equal to 3 times 2 times -1 to the 1 plus 1 power. Remember, we're starting n to be 1. So I have to adjust the power so that I can get that. That'll be 3 plus 2 times -1 squared. That's 3 plus 2 times 1, and that's 5. Second term is 3 plus 2 times -1 to the 2 plus first power. That's 3 plus 2 to the -1 to the third power. That's just 3 plus 2 times -1, and that gets me -1. So far, so good. The third term would be 3 plus 2 times -1 to the 3 plus 1 power. That equals 3 plus 2 times -1 to the fourth power. That will equal 5. So you see the formula is checking out. And that's what you have to do to sort of test your formula, is to write out maybe the first 3 or 4 terms and test your formula out. And I wanted to do this one because I felt it was kind of a hard one. Are there any questions on that? Any questions? Who's feeling reasonably comfortable? Maybe give me a thumbs up if you're reasonably comfortable so far. Okay, kind of. All right, I'll take that, Jonathan. I'll accept that. Okay, well now I want to look if we're good. Let me give you just another moment in case you need a little more time to copy. One moment. Okay, let's go to the next problem here. So this one here, actually, that's not the next one. Hold on. Let me see here. Give me one moment, class. Let me find it. Hold on. All right, I'm going to do this off of the whiteboard. I'm going to do it off the whiteboard. Let me see here. Get the whiteboard up. I mean, there's lots of examples. Let me see here. What's this mean here? Okay, no, let's clear it. All right. So let me ask you this. So we're still in section 8.1. Does the following sequence converge or diverge? That converge means the sequence reaches a limit. So here's a sequence. Okay, a sub n equals n over 2n plus 1, where n is 1, 2, 3, 4, and so forth. For the solution, okay, they made it a lot easier now to use this Blackboard with this update. Okay, what's the first term going to be? What's a sub 1 going to be? 1 over 3. That's right, Mohammed. Good. What's the second term going to be? Good. 2 over 5. So are you seeing this? A sub 1 is just 1 over 2 times 1 plus 1. That gets you a third. A sub 2 is just 2 over 2 times 2 plus 1. That gets you 2/5. Let's keep going. What's the third term going to be?
3, 7.
Good. All right, let's keep going. What's the next term going to be? 4 over 9. Good niya. Next term, 5 over 11. All right. We can keep going. What do these terms seem to be approaching? Good, a half. And that's right. So we can say this sequence, let me say it another way here. Hold on. Hold on. Okay, I'm in class. All right. Thanks. So since the limit as n approaches infinity I have a younger brother I live with, and he's been very good about giving me, about like having kind of a quiet atmosphere here for my teaching. So thank you, Kurt. All right, give a shout out to my brother there. All right, so the limit equals a half. So therefore, since that's the case, the sequence converges. Sequence converges. So if a sequence doesn't converge, it diverges. And we can get real fancy and stuff and about these sequences and we can get kind of fancy in how to show they converge or diverge and or how if they converge, what do they converge to? But honestly, at least for the simple sequences, you really want to try to use your intuition. Okay, you really want to try to use your intuition. So this sequence converges to a half. Now, I will tell you here. Let me just go into Desmos for a moment, if we're good. Is everybody good so far? Desmos can be very helpful for graphing sequences. So this particular sequence here, okay, what I did was I went into Desmos. Now, how you graph a sequence works a little bit differently. So what you see there is first you have to create in Desmos what's called an element list. And my element list, I'm graphing the first 10 elements of the sequence. So the sequence like for number 1, I put n equals 1, 2, comma, dot, 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 10. So I'm gonna plot 10 points of the sequence. The second part is the formula for the sequence, and then the third part gives me like the dots. Okay, so if I wanted to be a little more careful here, I could bring the wrench up, and since the sequence, I always like to include 0 in my x-axis. My y-axis, there's a lot of wasted space here, so I can maybe do like this. I can just try to have a judicious choice here. And you see, there's the sequence. Now hold on here, hold on. No, wait. Oh, it's n over 2 times n plus 1. I'm sorry. I got to put a 2 here. There we go. All right, so let me just see here. Let me just adjust the graph a little bit. I always like my origin to be in my picture. There we go. That's a little better. So do you see what the sequence is doing there? As like on the axis there, you have n equals 1, 2, 3, 4, all the way up to 10, and it looks like it's approaching something, right? Well, look, what we can do is we can change this to 100. We can change this to 100, and I can go to my wrench, and on the x-axis, I'll go out to 100. Okay, so you see there's a plot of the sequence, and this is going to be very helpful for some of your homework problems for section 8.1 that are due on Monday. Now I have to get that assignment ready. You're not ready to do that yet. You're working on 7.4, but look at what I can do here. I can touch. See, like the 42nd term of the sequence is 0.4941. Okay, well, let me go a little further into the sequence here. Let me go a little further into the sequence. Let me touch this dot. Okay, the 79th term of the sequence is 0.4969. The let's see, let me go out to the 98th term of the sequence is 0.4975. So as n increases, as we move further out into the sequence, what do the terms of the sequence seem to approach? Well, 0.4941, 0.4969, 0.4975, all those terms, those sequences, the values of the sequence are approaching what? So you have the 42nd term, which is 0.4941. 79th term is 0.4969. 98th term is 0.4975. And that's right, a half. So how many think they might use Desmos to help them with section 8.1? Okay, Yamtan's going to use it and Clay is going to use it. Excellent. And that's really, you know, a nice, good introduction into section 8.1, what I showed you here. And you can, you know, you can do this for a variety of sequences, right? Are there any questions before I stop the recording? Okay, let me stop the recording then. Very